It was Carl Sagan's idea, changing Voyager's 1 mission from science to reportage, if only briefly. Now, the Voyager, which you see here before launch, was launched on September the 5th, 1977, a space probe that was destined to set course for Jupiter and Saturn and observe the 2 gas giants and send back data that have indeed revolutionized our understanding of planetary physics. But once the job was done, the scientific mission achieved, this probe, the size of a small car, was to keep going for as long as possible, eventually getting lost into interstellar space, conserve power, and keep in touch with us on Earth, sending back whatever data it could. It is still doing so today, more than 40 years after launch, and it's reached the end of the solar system, 4 billion miles away from us, past the orbit of Pluto. On board the Voyager 1 and its twin, the Voyager 2, a golden disk was a late addition to the mission, which you can see here being prepared to be mounted before launch. This was also Sagan's idea, because he knew that the probe was destined to leave our solar system and that in about 40,000 years, it will brush past another star, 17 light years away from us. So he assembled a cross-disciplinary team to put a cosmic postcard on this golden disk, an interstellar postcard that could be understood, hopefully, by any sentient being that might one day pick up the Voyagers. On the cover of the golden disk, a set of instructions are etched and designed to withstand the trials of deep space travel. And the instructions tell the future hypothetical aliens how to play the disk, that it needs to be spun at the frequency of 16.5 rotations per minute, units of the fundamental frequency of hydrogen, which is also depicted. The location of our solar system in the bottom left is given with respect to 14 pulsars, and an ultra-pure layer of uranium-238 is spread across the surface to act as a kind of clock that will run down with a half-life of 4.5 billion years. So the alien hand, if it is a hand that will potentially one day remove the disk from the encasement on the side of the Voyager, will find behind it the stylus that's needed to play it and reproduce the contents, as well as this picture, the test picture that you can see etched on the surface will tell them whether they got it working right. And if they are successful, one day, in one faraway corner of the galaxy, sounds and picture of 1970s Earth might rise to life once again. The song of whales, the sound of a mother kissing her baby, Mozart's Queen of the Night area, the structure of DNA, bushman hunting, traffic jam in Thailand, the Sydney Opera House, a young woman eating grapes in a supermarket aisle. Now, it's impossible to imagine what kind of impression these sounds and sights might make on the sensory organs of a life form that we can scarcely begin to conceive. But Sagan's second momentous idea, apart from the golden record, was to use Voyager's unique vantage point, almost 4 billion miles away, to take this iconic picture, a picture that is now known, the pale blue dot. Earth is the pixel floating in this beam of light in the blue circle in this picture, seen from 4 billion miles away. And in the book of the same title, The Pale Blue Dot, Carl Sagan wrote, "Look again at that dot. That's here. That's home. That's us. On it, everyone you love, everyone you know, everyone you ever heard of, every human being who ever was, lived out their lives. The aggregate joy and suffering, thousands of confident religions, ideologies, and economic doctrines, every hunter and forager, every hero and coward, every creator and destroyer of civilization, every king and peasant, every young couple in love, every mother and father, hopeful child, inventor and explorer, every teacher of morals, every corrupt politician, every superstar, every supreme leader, every saint and sinner in the history of our species lived there, on a mote of dust suspended in a sunbeam." Now, Sagan must have known fully well that the probability that anybody will pick up the golden record is vanishingly small. So the messages on the golden record were directed as much to a potential alien civilization as they were to a public much closer to home, us, the inhabitants of planet Earth. Sagan's heartfelt message was that humanity needs to take good care of our pale blue dot, the only place in the universe we can call home. Seen from 4 billion miles away, the absurdity of humankind's hatred for each other, the blood spilled to conquer a fraction of a pixel floating in empty darkness, the wrecking of the natural world that supports us appear in all their foolishness. He was also concerned to existential threats to life on Earth coming from space, particularly the danger of an asteroid strike, a plot that's been dramatized in many Hollywood disaster movie, and we've seen played out on screen many times. And in fact, we do know that asteroid collisions have happened in the past, and that they yanked the course of evolution on our planet, perhaps multiple times. For example, the moon might have formed when a hypothetical body, a planetary embryo that is called Theia, impacted the half-formed Earth 4.4 billion years ago. Now, the existence of a large moon today might have been, and in the past, might have been fundamental in giving evolution a chance to proceed and give life the complex form that it has today, because the presence of a large moon has stabilized the Earth rotation axis, preventing it from wobbling about much more than it would otherwise have. And if that would have been the case, then the climate of the young Earth would have changed much more abruptly than it did, and therefore potentially preventing evolution from giving rise to life as we see it in our world today. Also, when ocean-based life forms appeared in the young Earth, the strong tides created by the moon have been instrumental in giving life a foothold on land. And so this was the pathway that eventually led to mammals and humans. So if Theia's impact was life-giving, the asteroid that hit near the Gulf of Mexico some 66 million years ago caused enormous disruption to life, as we are all aware. With it, it also opened, though, new opportunities for evolution. Now, the impact of the 12-kilometer wide space rock that generated these apocalyptic tsunamis and also spewed into the atmosphere enormous quantity of vaporized rock was bad news for the dinosaurs, who got extinct as a consequence of the climate change that ensued. The climate cooled, plants died out, and the entire food chain collapsed. 75% of all species on Earth were wiped out. Among them, all the animals weighing more than 25 kilograms, including all non-flying dinosaurs, which is bad news for the dinosaurs, but it was great news for us because it blew wide open a window of opportunity for mammals to prosper in the void left by the giant reptiles. And of course, millions of years later, here we are, the descendants of those very mammals, naked apes equipped with nothing more than an oversized brain and an opposing thumb, which were instrumental in creating our civilization. And now, millions of years later, we excavated the fossilized remains of the dinosaurs. We marveled at these otherworldly creatures, and we eventually built cuddly toys that are loved by all kids all over the world, and all thanks to this asteroid impact. Now, in more recent times, so-called Tunguska event was caused by an explosion of a meteor of about 50 meters diameter in mid-air. This disintegrated over Siberia in 1908. And thankfully, this happened in a sparsely populated zone. Reports say that only about 3 people lost their lives because it was in the middle of a forest. But as you can see from the picture, this blast, in fact, flattened over 2,000 square kilometers of forest. It could have had much more disastrous consequences if it had happened in a more populated region. Now, meteors of this kind are nothing else but space rocks, which are called asteroids, that are captured by the Earth's gravitational pull. Most asteroids orbit the Sun in a region called the main asteroid belt between the orbit of Mars and Jupiter. And they are the leftover debris from the formation of the solar system some 5 billion years ago. They can be ejected from their stable orbits by gravitational interactions, and they can be hurled to planets, like in this case. Fortunately for us, large asteroids of the kind that could cause wreckage to life on Earth are much rarer than smaller ones. And in fact, we know, if not in the form of asteroids, but we do experience the fall of space debris and little rocks and little pieces of comets when we look at meteor showers, for example, just smaller pieces of rocks that blow up in the atmosphere as they re-enter. Now, NASA defines potentially hazardous objects as those with a diameter larger than 150 meters, and that are on orbits that approach the Earth to fewer than 7.5 million kilometers. There are about 2,200 of them. You see here, the orbits here tracked currently by NASA in an effort to making sure that they stay well away from our planet, although, of course, if they were to veer towards us, very little can be done to stop them. The frequency of an asteroid strike of the kind that could be dangerous for life is estimated to be once every 200,000 years. Now, there are other bodies, of course, that visit our neighborhood with regularity, with a certain frequency, like comets, for example. Nothing else but balls of ice and rock that typically travel on very elongated orbits. Halley's Comet, for example, is a famous example that faithfully returns every 76 years. And if you missed it in 1986, you got another chance in several decades. I probably won't see it again. But in 1994, we've been able to observe something very spectacular, the fall of the debris of the comet Shoemaker-Levy 9, which broke up because of gravitational interaction with Jupiter and eventually crashed onto the planet. Now, Jupiter being much bigger than the Earth, it's got a much bigger gravitational pull, and so thankfully it acts as a kind of cosmic vacuum cleaner, sweeping up lots of comets and debris and asteroids. And you can see in this picture, the dot is the explosion or the hit or the impact of the comet fragments onto the dark side of Jupiter with an estimated power of 300 million atomic bombs. So what about other threats to the future of life on Earth from space? Well, another long-term danger actually comes from the very source of energy that enables us to live on our planet, our very own star, the sun. Nuclear fusion reactions convert hydrogen into helium in the core of the sun, and therefore are the source of all the heat that enables us to live in a habitable zone on this beautiful planet. This is a very stable phenomenon inside the sun. In fact, the sun today is a middle-aged star, having been burning hydrogen for about 4.5 billion years. And this is something that's likely to continue for the next 4 billion years or so. But as the hydrogen supply at the core of the sun dwindles, other stars, more massive than the sun, will be able to switch to a different supply of fusion, namely helium. The sun, however, is not sufficiently massive to ignite helium in its core, and so the core will fill up with inert helium. Hydrogen fusion will move to a shell outside the core, and as a result of that, our star will blow up and expand. And it will become, eventually, a red giant. In 5 billion years, the sun will have expanded enough so that its surface will encompass the orbit of the Earth. And so our planet will essentially be incinerated in the process. However, well before that happens, in 1 billion years, the sun's output will have increased by about 10%. So this increased brightness and temperature will make the water in our oceans boil away. So we've got about 1 billion years to go before that happens. Now, 1 billion years, that's nothing to worry about. Let's be honest about it. To put this in context, 1 billion years ago, where was life on Earth? Life on Earth was still in the form of single-cell organism. In fact, on much shorter time spans, a much more dangerous potential development and of the consequence of the natural life of our sun is actually solar storms. Solar storms that might not threaten life on Earth, but certainly might threaten and will threaten our technological civilization. Now, solar storms are a consequence of the reconfiguration of magnetic fields on the surface of the sun, twisting and snapping in correspondence to the sunspots, the cooler dark patches that you see that appear as dark spots on the surface of the sun. The magnetic energy that is released in this process is released in the form of heat, light, and charged particles that travel outwards, and sometimes in the form of solar flares, a massive eruption of plasma like the one that you see depicted in this picture. So this very hot plasma can be heated up to the inconceivable temperature of 60 million Kelvin and travel outwards into space, hitting whatever is on its way, including our planet. So this kind of solar storms are, fortunately for us, we are protected from them by the Earth's magnetic field. And so the most spectacular consequence of these solar storms is nothing else but the aurora borealis, which gives us spectacular displays. And in fact, in 1859, when the largest recorded solar storm happened, the aurora borealis, northern lights, was so spectacular and so massive that it extended all the way to the Caribbean, where it's usually not visible. All that happened in 1859 was a massive disruption of telegraph lines, because that was essentially all there was in terms of electrical infrastructure at the time. But imagine what would happen today if a solar storm of that magnitude were to hit us, dependent as our civilization is on, you name it, internet, GPS, navigation, satellites, telecommunication, electrical power lines, it could all be fried. And if that would not necessarily be a threat to life itself, it's clear that our entire navigation, security, economic, financial systems would go down for lack of infrastructure. And therefore, certainly our civilization could be threatened by the anarchy and chaos that could ensue. Other stars have lives that are more adventurous than the Sun. Rather than just swelling and cooling off, eventually retiring from active stellar service like the Sun will do in 4 or 5 billion years as a dozy white dwarf, other stars that are more massive than the Sun will burn recklessly through their hydrogen supply, and then after just a few million years, we'll move on to the next one, helium, and then carbon, neon, oxygen, going through the heavy elements, fusing always elements into heavier ones until eventually they run out of nuclear road. They reach silicon, and silicon can be fused into iron, and when you get to iron, that's the end, because you cannot fuse the iron into anything else, anything heavier, unless you supply energy. So it becomes a losing game, gravitational collapse wins out, and the star implodes in a collapse that is called, that gives off a lot of energy, and is called a supernova explosion. This mighty explosion destroys the star, and it explodes, spewing out all of these heavy elements that it has produced during its lifetime. And in fact, it has been suggested that in the past 10 million years, 2 supernova explosions might have been close enough to Earth to alter the Earth climate with their influence. More recently, the supernova that you see in this picture at the center is the bright dot with the rings of gas expanding. Supernova 1987A in the Large Magellanic Cloud was such an occurrence. There is also a second kind of supernova explosion called Type 1A that is of a different kind. Luckily for us, 1987A went off 168,000 light years away. So by the time the energy and the light and the X-rays of the explosion reached us, they were diluted by distance, and it wasn't dangerous for us, although it was very important for astronomers and astrophysicists. We learned a great deal about neutrinos, for example, from this explosion. But it's clear that a supernova explosion of this kind, within 25 light years from Earth, would likely wipe out life with its flux of X-rays and gamma rays. But luckily for us, there are no stars that are likely to go supernova within that radius, so the nearest candidate is Betelgeuse, the star in the upper left corner of Orion, the familiar winter constellation. A red giant that you might have heard from the news caused some concern in 2019 because it was dimming. It dimmed over the course of a few months quite significantly from its normal brightness. And it has reached, and this is thought to be a consequence of the convulsion of the end of life that Betelgeuse is reaching. It's probably got another 100,000 years to go or so. So again, nothing to worry about. And when it does go bang, there are 550 light years between us. So that means that future astronomers, if there are any, might be treated to a great spectacle without having to worry too much about the danger for life on Earth. And we should really remember that supernova explosions, as dangerous as they might be, they were absolutely crucial in producing and then spreading through the universe the heavy elements on which life is based. The violent death of supernovae can be and is a source of destruction, but it can also be a fountain of life, literally providing the elements of which planets, trees, cats, cheese, humans, everything is made. But there is something else out there that might overrun us with deadly consequences, and do so in a way that we would not even realize until it's upon us and too late to do anything about. And quite frankly, there is nothing to do about it. It has been called the ultimate ecological catastrophe. The possibility that empty space itself, or more precisely what physicists call the Higgs boson field and the vacuum, might spontaneously change. Now, you might think that what you can't see can't hurt you, and how dangerous can the vacuum be? It's empty. But actually, well, let's take a step back and consider this scenario. A ball sitting on top of a hill and 2 valleys either side, one deeper than the other. It's clear that this situation, if the ball is finally poised on the top of the hill, is unstable. The slightest perturbation will make the ball roll down one of the two hills, and eventually, because of friction, it will end up just sitting at the bottom of the valley that it happens to roll into. Now, this situation for a classical object like a ball is stable. The ball will just sit there for all eternity. There is no way the ball can go from the valley it sits in to the deeper valley where its stability would be improved. If we could put the ball in the other valley, in the deeper valley floor, it would improve its stability because it would have a lower gravitational potential energy. But in order to do so, you have to supply kinetic energy to the ball. You have to give it a kick so that it overcomes the barrier between the two valleys. That's all very well in macroscopic reality, but if we consider the quantum world, then things become a little bit weirder. In particular, the ball sitting in that valley is now metastable. It's not entirely stable, and there is a finite, non-zero probability that it will be able to quantum tunnel, that's to say traverse, the barrier between the two valleys and eventually end up in the stable configuration in the deeper valley on the other side. So this classically impossible quantum tunneling is a familiar phenomenon in quantum mechanics. It happens all the time, and in fact, it's responsible for example, alpha decay, which explains radioactivity of uranium-238. So now let's make another conceptual jump from this picture that's already quite weird, and imagine these crest and valleys to represent the Higgs potential, which describes the quantum mechanical analog of potential energy for the Higgs boson field, which permeates the whole universe. Now, the Higgs boson, you might have heard, remember, was measured, its properties and its mass and its existence was discovered in 2012 at CERN. And it turns out that the mass of the Higgs boson and that of another elementary particle called the top quark have allowed to determine the configuration of the Higgs field in the entirety of the universe. And what it has been discovered is that the configuration of the field, which you can imagine as some sort of invisible entity permeating the entire universe, is currently in its metastable state. It sits in a valley, but it's not the deepest valley. It's a valley, and potentially it could go somewhere else in a different valley with a lower configuration and therefore better stability. And there's a finite probability that this might happen. So the Higgs field configuration found itself in the metastable configuration 13.8 billion years ago when the universe came out of the Big Bang, and it has been sitting pretty there ever since. But it could potentially quantum tunnel to a lower energy configuration into the true vacuum. So this metastable configuration is called a false vacuum. So if that were to happen, the Higgs field would reconfigure itself, end up in the deeper valley, and should that happen anywhere in the universe, the field reconfiguration would propagate out in a spherical shell almost at the speed of light, overrunning everything in its path. So what would that look like, this Higgs field reconfiguration spread into the universe? Well, nobody really knows. But it is likely that the physics inside the bubble will be very, very different from the physics outside the bubble. So we would be overrun by a change of the laws of physics, meaning we would just be gone at near the speed of light. So from one moment to the next, we could be gone. There would be nothing to do about it. We would just be obliterated with a backhand flick of the Higgs vacuum. How worried should we be? It's quite bad, frankly. Well, it's very, very difficult to compute the lifetime of this metastable state. The calculations are daunting, as you might imagine. A group from Harvard estimates the lifetime of the universe to be somewhere in the region of 10 to the 161 years. So that's 10 followed by 161 zeros. By comparison, the lifetime of the universe to now, it's 10 to the 10 years, so much, much shorter. Another calculation gives an estimate in excess of 10 to the 600 years. So either way, the metastable state of the Higgs vacuum seems to be pretty solid, so we shouldn't be too worried about it, to be honest. One can also take a statistically minded approach to this question. What are those dangers out there statistically doing in terms of what is the probability of us being wiped out by a cosmic catastrophe? Cosmologist Max Tegmark and philosopher Nick Bostrom have noted that life, having survived for 4 billion years on Earth, cannot per se be used as an indication of how rare cosmic doomsday events are. Because if you think about it, the fact that we are here asking that very same question would necessarily mean that we've been the lucky ones who have escaped cosmic catastrophe, no matter how frequent cosmic catastrophe is. If we would have been befallen by cosmic doomsday event, we wouldn't be here to ask the question. Instead, they considered the rate of formation of habitable planets in the universe as a function of time, and they noted that life has evolved about 9 billion years after the Big Bang. They concluded that cosmic sterilization events strike at most once every billion years with 99.9% confidence. So they argued that this limit encapsulates all of the natural dangers to life in the universe, except the anthropogenic ones, the ones that we create on our planet, to which in a moment we'll turn our attention. So if Bostrom and Tegmark are right, then life-sterilizing events happen on average every billion years. So you may worry that we might be already overdue because we have been dodged cosmic catastrophe for over 5 billion years on Earth, and therefore we have been lucky already. But there is a surprising statistical property of the exponential distribution, which is the distribution that controls the waiting time between events that happen at a constant rate, such as the ones that we're talking about here. And that comes to our rescue. Having waited for 4 billion years for a cosmic sterilization event to happen and not having experienced one, luckily for us yet, has no bearing on the amount of time that we can expect to have to wait for the next cosmic sterilization event to happen. It is still 1 billion years. So we got lucky in that respect. But the fact is that in searching for the most imminent and present danger to life on Earth, we don't need really to invoke Newtonian orbits, stellar evolution physics, or the exotica of quantum field theory to work out the Higgs vacuum stability. It is sufficient for each of us to look around us in this room or in the morning in the mirror, because the most present and palpable danger to the future of life on Earth is not out there. It's in here. It's us. When we consider the future of life on Earth, we must first and foremost ask the question that Jonas Salk, the inventor of the polio vaccine, posed. Will future generations speak of the wisdom of their ancestors as we are inclined to speak of ours? Are we being good ancestors? Now, at the beginning, the naked ape that we call Homo sapiens seemed harmless enough. The use of fire, stone, wooden tools helped our ancestors survive in a world that was full of better-equipped predators, where food was a scarce resource, dangers aplenty, and life a constant struggle. But then, 50,000 years ago, our most powerful weapon somehow came into existence: language, and with it, abstraction. Now, the wheel of technological innovation began to spin in earnest. In a short 10,000 years, the naked ape built cities that light up the night, space stations that circle the Earth, works of art that move the soul. We sent 12 of us to play golf on the moon and created weapons of unimaginable destructive power. Yet, this technology that is often indistinguishable from magic, as A.C. Clarke once put it when describing futuristic tech, has somehow failed to be put to the work for the benefit of all. Millions of people die of premature death due to obesity, heart attack, and other illnesses related to overconsumption of heavily processed food, while millions of others go hungry and are undernourished. Income inequalities are higher than they've ever been. The richest 10% own 3/4 of all wealth, while the world's 10 richest men have seen their wealth double during the pandemic. Mastering our own tech seemed never to have been our forte, and making sure that the almost godlike powers that it confers on us, making sure that those serve all of humankind, has never been our strong suit. Let me quote you some words, the origin of which will become clear in a minute, but whose importance, I think, is ever more urgent today than it was when they were written. What the inventive genius of mankind has bestowed upon us in the last 100 years could have made human life carefree and happy if the development of the organizing power of man had been able to keep up with its technical advances. As it is, the hardly bought achievements of the machine age in the hands of our generation are as dangerous as a razor in the hands of a 3-year-old child. These words were written by Albert Einstein in 1932, ahead of the disarmament conference, and they are even more urgent today than they were when they were written. Those words are words that Einstein surely pondered later in life when the nuclear destruction brought about in Hiroshima and Nagasaki by the weapons that he helped motivate to create put a new urgency to the problem of disarmament, something that Einstein clearly regretted bitterly for his whole life. In the meantime, since Einstein wrote these words 90 years ago, our numbers have doubled. There's about 9 billion of us on the planet now. And thanks to science and technology, of course, we have been able to lengthen our lifespan, wipe out diseases, reduce infant mortality, and for a minority of us, we've created a world where our almost every material whim can be satisfied at will in a 2-hour delivery window. In the words of a character of Richard Powell's powerful novel, The Overstory, we're cashing in 1 billion years of planetary savings bond and blowing it on a sorted bling. But the price that we will eventually pay is enormous. 40% of our world's land is now degraded, according to a recent UN report. Deforestation continues unabated, destroying irreplaceable ancient forests, while intensive farming creates salinization, soil exhaustion, erosion. The havoc that the naked ape is wreaking on the planet is striking from space. Our beautiful blue planet is scarred in ways that would have been unimaginable just a generation ago. By clear-cutting 1,000-year-old forests to make space for palm oil plantations that will fail within a decade, we are undercutting the very basis of life on our planet. On land, we have tilted the balance of animals to suit our needs. We now have a staggering 10-to-1 preponderance in weight from farm animals compared to wild animals. The oceans, which once seemed to be an inexhaustible resource, are overexploited. 90% of the fish stocks are either depleted or exploited, or fully exploited. Flying insects have crashed in the UK by 60% since 2004. After the forests and the oceans, we are now encroaching in the last remaining natural resource, space. The uncontrolled proliferation of low Earth orbit satellites, building up mega constellations of internet satellites that aim at providing internet connection globally everywhere at all times, is creating a real overcrowding of space in low Earth orbit, 250 kilometers up. You see here a graph of the number of tracked space debris, which is increasing very, very fast, as is the number of low Earth satellites. The mega constellations that the new space race, the commercial space race, is building are projected to increase the number of satellites from 6,000 today to about 100,000 in a decade. 100,000 low Earth orbit satellites mean the manifold increase in the danger of collisions between those satellites, collisions that would fill low Earth orbit with debris and would prevent future generations' access to space. And it's not only a matter of accessing space, it's also a matter of preventing seeing the beauty of the universe from Earth, both for the astronomers whose data, ground-based data, are being ruined by passing satellites. You see the streaks in this picture are being left by one mega constellation passing in front of one of the giant telescopes on Earth, destroying up to 50% of astronomers' data, and therefore preventing us from seeing the universe and seeing the distant galaxies and studying it. But equally importantly, these mega constellations are threatening our enjoyment of the night sky, the beauty of the night sky that has accompanied and guided civilization ever since humans looked up at the stars. And I will argue in my upcoming book that actually seeing the stars has been one of the driving forces of humankind's march through history. In 1849, Emerson sang the beauty of the night sky by saying, "One might think the atmosphere was made transparent with this design, to give man, in the heavenly bodies, the perpetual presence of the sublime." This perpetual presence of the sublime is being taken away from us. By 2030, there will be more artificial satellites visible with the naked eye than real stars. We won't be able to experience the universe anymore as our ancestors ever did. And therefore, it is no surprise that astronomers and environmentalists are joining forces in what is being, for making the case in what is being called space environmentalism. This is our last frontier of conservation. Even space is in danger of being overexploited. We have been here before. Passenger pigeons once numbered in their billions in the eastern United States. Those are sleek, slender, gregarious migratory birds that used to flock in huge numbers, immense flock that darkened the sky for days when they were migrating. There was a colony in Wisconsin in 1871 that was measured to be 125 miles long and 8 miles wide. Can you imagine that? They've been described as a biological storm, a feather hurricane. But in the late 1800s, in the space of just a few decades, they were exterminated as humans hunted them for flesh or even just as a pastime. Nobody could ever imagine that these enormous numbers could ever dwindle to nothing until it was too late to save them. The fate of the passenger pigeon is now faced by up to 1 million animal and plant species all over the world, driven to the brink by habitat destruction, poaching, climate change, of course. Our carbon-based economy is rapidly increasing the CO2 in the atmosphere to the point that the 7 past years have been the hottest on record. Global temperatures are up to 1 degree centigrade above pre-industrial levels. Glaciers are disappearing. The permafrost is melting. The ice cap is retreating. The sea levels are rising. Our planet has entered an out-of-equilibrium phase whose spiraling feedback loops will endanger the lives and livelihoods of billions of people sooner than we think. The passenger pigeon tragedy shows that once life is kicked out of balance, the abundance of life can crash surprisingly quickly, shockingly quickly. In the words of the anthropologist and poet Lauren Isley, we are a vast black whirlpool spinning faster and faster, consuming flesh, stones, soil, minerals, sucking down the lightning, wrenching power from the atom until the ancient sounds of nature are drowned in the cacophony of something which is no longer nature. How long can we tether on the brink before the fall? Now, in the face of these human-induced dangers and existential threat to life on Earth, some are arguing that it's time for us to flee to the stars, to build a modern-era Noah's Ark, not out of wood on a mountaintop, but out of steel on top of a rocket, and ensure the survival of the human race by fleeing to the stars, and therefore fleeing the actual and metaphorical flood that is coming. The idea is not new, and it was championed by Carl Sagan himself, actually, who saw it as an insurance policy against the not unreasonable risk that we might end up wiping ourselves out. A danger that has never been more sharply defined, perhaps, than today, when an horrendous war rages in Europe once again. He wrote, "If our long-term survival is at stake, we have a basic responsibility to our species to venture to other worlds." Today's space barons, the multi-billionaires that are transforming space into the final frontier of tourism, have picked up Sagan's flag. In fact, NASA's efforts to take humans back to the moon, and hopefully the first woman to the moon, hinge on privately built rockets. One of the much touted next steps is a mission to Mars. The date of such a mission keeps slipping back. Maybe 2029 is later now. This is a much more ambitious and technically difficult task than taking people to the moon. Don't get me wrong. A trip to Mars might take 6 to 9 months for a round-trip duration of a mission of about 2 years. The challenges are enormous. Prolonged exposure to cosmic rays, the need to take sufficient supplies along for the trip or else to produce them in situ on Mars, the difficulty of landing a large spacecraft on this planet, the psychological distress of being in very confined spaces for a long journey. Those are just the tip of the iceberg of the challenges of a mission to Mars, of a human mission to Mars. Establishing a colony on Mars, especially one that can survive independently from the Earth, appears today an even more tenuous prospect. Consider that in 2021, the International Space Station required resupply about every 6 to 8 weeks. And that is for a crew of 7, 250 kilometers away, is not for a colony of hundreds, perhaps 100 million miles away. Others claim that it might not be necessary to send our physical bodies there. We might just be able to jump over to the next step in the evolution and send silicon-based simulacra, perhaps, some sort of AIs that will be better at everything than we are, and therefore they will be better at colonizing another planet as well. So the next step of evolution would be to shed our biological form and live on in the cloud. Now, given the current state of AI, I doubt that this is very feasible in our lifetimes, and even if it could be realized, these artificial life forms that are supposed to replace us would be fundamentally other. Frankly, I doubt that the Neanderthals would have been pleased to be told that they were to be exterminated only for a superior species to take their place. And even if it were possible to build Sagan's Ark, our technology, frankly, is not today up to the task, but even if it were possible, there would be space for only one species on it, us. There would be no space for whales, falcons, or butterflies. No meadows full of bluebells, no 1,000-year-old redwoods, no coral reefs, no bees, no earthworms, no sounds of crickets on a warm summer evening. For that matter, there would be no warm summer evening, because if, Mars being a desert planet, evenings are quite chilly. It goes down from minus 14 degrees on a hot day at the tropics to minus 90 degrees at night. So not very pleasant. Escaping to another planet, leaving an ecologically compromised Earth behind as an empty husk, would be the ultimate outcome of what the philosopher of technology Louis Mumford called the mega machine. The relentless focus of Western civilization on organizing and corralling the entirety of human existence into an ever more efficient, ever more powerful, and therefore more destructive mechanized order of the world. Eiseley's insights comes to mind. Man has become a space leaper more deadly than the giant cats. To Sagan's basic responsibility to our species to guarantee our own survival, I would oppose the moral imperative of our stewardship of the whole planet and its countless billions of life forms that our reckless choices have put in mortal danger. How ironic that we should launch ourselves into space, venturing at great effort to eke out a living out of inhospitable, barren planet, while at the same time doubling down on our efforts to wipe out all life forms from our own blue, beautiful home. Writing in the 60s at the onset of the space age, Mumford presciently described the pyramids as the precise static equivalents of our own space rockets. Both are devices for securing, at an extravagant cost, a passage to heaven for the favored few. That's a second ethical argument for rejecting Sagan's Ark and its dash to the star, for it's only the favored few, read the richest few, who would ever hope to gain passage on these hypothetical interplanetary lifeboats. Indeed, those are the very same men that are today building the very same rockets on which they take joyrides in space. According to one of them, about perhaps 50% of Silicon Valley billionaires are doomsday preppers. Those are people who buy apocalypse insurance in the form of well-stocked bunkers in remote locations guarded by private militias. They have private planes to get there in case apocalypse strikes in the form of climate change, a deadly virus, nuclear war, or civil disorder, perhaps precipitated by the very mega machines that they have helped build. They want to secure a way out for themselves and their loved ones. And if the whole planet is burning due to climate change, then space is the ultimate escape route. Efforts to colonize the solar system to escape dangers on Earth are both practically and ethically misguided. Insofar as Sagan's argument goes, I would counter that when your car starts skidding during an overtake maneuver on the highway, that's not the time to reach out for your phone and call your insurance broker. It's the time to focus your efforts on regaining control of the vehicle before it's too late and stave off the worst for all of its passengers. In fact, ethically, space colonization deflects attention from the real issues by offering a false hope of salvation. If only we could get advice by older, wiser civilizations out there, or else if we could be spurred into acting by witnessing, thanks to our telescopes and other instruments, the cosmic demise of a civilization elsewhere in the cosmos, and witnessing their planetary catastrophe might spur us into actually doing something about our own predicament. We don't know of any other life forms in the universe yet, although the last 2 decades of observational advances have seen mighty steps forward in our ability to detect life on planets orbiting other stars, so-called exoplanets. We now have a catalog of several thousands of them, of which many are potentially in the habitable zone, the zone that could support biological life forms. In fact, we estimate that about 50% of the planets in our galaxy might have a planetary system, and if only 1 in 1,000 such systems could potentially harbor life forms, then this makes 150 million opportunities for life to arise elsewhere in the Milky Way alone. The majority of those potentially life-friendly planets might be found actually in close orbits around red dwarf stars, very unlike the Sun. The conditions there would be very different than from Earth. You would have a planet orbiting a star in a matter of days rather than in a year. And the proximity of planet and star would mean that the planet would always show the same face to the star. The orbital period and the spin of the planet are synchronized. So you'd have a planet that is where one half of the planet is in permanent daylight, potentially too hot. One half of the planet is in permanent darkness, potentially too cold. And the transition zone between the two might offer the ideal opportunity for life to arise. And you would imagine this, this place, exotic place with this giant red star hovering just above the horizon in permanent twilight. There wouldn't be an alternation of day and night. There is no doubt that evolving in such a different environment, life would take unsuspected turns. The human experiment is unlikely to be replicated exactly the same or even in vaguely recognizable form anywhere else in the galaxy. But perhaps the better question is not to ask where the aliens might be, but for how long do they thrive and when do they arise? Now, consider the following. If we compressed the entirety of life, the entire history of life on our planet, 4 billion years, in just 24 hours on a clock, from midnight to midnight, then multicellular life forms wouldn't appear until about 8:30 in the evening on our planet. Mammals at about 10 to 11. Neanderthals, 9 minutes to midnight. Humans, 25 seconds to midnight. Man-made radio signals into the cosmos, 0.05 of a second to midnight. This is just a flash in the entire history of life. And so if life exists elsewhere in the universe, and it might be widespread, it might be that the kind of life that is able to send out radio signals or is able to make itself recognizable from a distance might not be all that widespread. So there are two explanations why we haven't heard from aliens yet. The first, civilizations with interplanetary communication capabilities might be rare. After all, the Neanderthals, who definitely qualified as intelligent life, stuck around for 1 million years in what was described as technical monotony. They never evolved advanced technology. But the alternative is far more worrisome for us. It may be that civilizations that do develop mega machines quickly flicker out of existence, snuffed out precisely when their technological power brings about the means of bringing about their own demise. In this scenario, the deafening absence of signals from outer space might foreshadow the curtain of silence that might soon fall upon us. Our survey of the conditions of life on Earth and of the dangers that threaten it in the 21st century leads to an unescapable conclusion. The future of life on our planet will not be determined by astrophysical phenomena that have timescales of hundreds or thousands or millions or even billions of years. It will be determined by human decisions that we will take in the next few months and years. Can we avoid nuclear incineration and a catastrophic ecological collapse? The horrendous COVID pandemic demonstrated, if nothing else, that we can make huge changes to our way of life when a present and palpable danger focuses our minds. Individual and collective actions can and do change the course of history. It is up to us to achieve the shift of perspective that enables us to see humanity as part of the whole ecosystem and to recognize the essential commonality of our cosmic destiny. Perhaps space tourists might end up having a good side. Seeing Earth from above, delicately suspended in the blackness of space, brings home its fragile beauty, so I'm told, and has a profound existential impact. Certainly it has had a profound impact on astronauts and space tourists alike. Among them, some of the most powerful men on Earth. Whether this will have a long-lasting effect on their individual and commercial choices remains to be seen. While you've been following this lecture, the Voyager 1 has silently traversed another 60,000 kilometers of almost empty darkness in the outskirts of the solar system, edging towards the star Gliese 447, which will reach in 40,000 years, 17 light years away. The Voyager will roam the galaxy for something close to eternity. The timescale for a collision with a star is 10 million times the age of the universe. Among the sounds, pictures, and greetings on the Golden Record is a message by the then US President, Jimmy Carter. Written in 1977, Carter's words ring with even greater urgency today. Of the 200 billion stars in the Milky Way, some, perhaps many, may have inhabited planets and space-faring civilizations. If one such civilization intercepts Voyager and can understand these recorded contents, here is our message. This is a present from a small, distant world, a token of our sounds, our signs, our images, our music, our thoughts, and our feelings. We are attempting to survive our time so we may live into yours. We hope someday, having solved the problem we face, to join a community of galactic civilizations. This record represents our hope and our determination and our goodwill in a vast and awesome universe. Whether or not we believe that we will one day join a community of galactic civilizations, it is our urgent task to halt the mindless march of the mega machine, to repurpose its planetary power so that it may serve the needs of all life on Earth, to fortify our hope and our determination, not merely to survive our time, but to create a new time, free of the dangers we are inflicting upon our planet and upon ourselves. Should anybody come looking for Earth in the distant future, guided by the 14 pulsars on the Golden Record's cover, will they be disappointed to find a dead planet, a cosmic tombstone marking the failed promise and the misguided hubris of the naked ape? Or will they marvel from the orbit of Jupiter already at our beautiful blue dot, sparkling delicate and majestic against the darkness of space? Our actions today will determine not whether we can be good ancestors, but whether we may become ancestors at all. We cannot afford to fail. Thank you.
How important is it to distinguish between the end of the planet itself, as the sun becomes red giant, and the end of the lifestyle of a proportion of its human inhabitants?
Right. Indeed. And in my talk, I've tried to speak to both of those concerns. And I think the bigger concern, of course, is for the impact that we as humans have on the entire biosphere of Earth. Because, you know, you can imagine we being so destructive as to destroy the entirety of life on the planet. That is not impossible, but you could also imagine that a catastrophe of the kind that I've described could wipe out a large majority of life, but life would eventually recover in the vast majority of scenarios. So I think it is first and foremost a question of deciding we as human species, as the dominant species, technologically dominant species, are we ready to revise our lifestyle and our expectations of what our lifestyle can be in order to make space, first of all, for our fellow humans who do not enjoy our lifestyle currently, but also to make not just space, but to leave the space for the biosphere at large, because the fact of the matter is we are using resources at a far higher rate than the planet can afford. And these choices that we're making now in just a few decades will come back to hunt us and our descendants. We cannot afford to go on like this. So doing what's right for the planet is also doing what's right for humankind, I would say.
Yeah, so to bounce back on that, would you say that actually we're more a danger to our planet and everything around us than ourselves? Because as you said, we're advancing technologically very, very quickly, and actually by the way things are looking, we can counter our own effects, but we can't counter the effects on everything else. So would you say that we're more a danger to the planet itself than we are to humankind in that case?
I think the two questions are interlinked, precisely because we tend to see ourselves as being insulated from natural environment, and because of our technology, which by and large, we live in a city like London, which is a great city, but it's completely dependent on supplies, energy from the wider environment, of course. And so we tend to see ourselves as being insulated, but the pandemic certainly has shown how everything now interconnected and interdependent is, and the ultimate substratum on which all of this chain of dependency rests is the biosphere. So wrecking the biosphere is akin to sowing the very bowl we're sitting on, and the effects can propagate shockingly quickly. Think of what's happening with the overexploitation of fisheries, for example, and the livelihoods of millions of people are at stake through that. So we're not an insulated part from the environment. The environment is what supports us, and we've been exploiting it far too high a rate for far too long already.
Oh, thank you. At the beginning of your talk, you outlined possible global destruction due to asteroids. That sort of threat would seem minuscule compared to our own behaviour in terms of environmental destruction and nuclear conflagration. Would you agree that we've inflicted more chance of destruction ourselves than that from outside astronomical sources?
I think so, absolutely. I would agree with that. And I think, the asteroid strike is something easy to picture in your head, and there are many movies that play along with this disaster scenario and so on and so forth. And therefore, it's something that perhaps strikes our fantasy as being more imminent or more dangerous or more risky than it actually is, while the chain of relatively hidden reactions that are happening in terms of our destruction of, destroy the Amazon forest, and this has got a global consequence on climate. It's something that plays out quickly on the timescale of the planet, but relatively slowly on the timescale of a lifetime, although we've seen accelerating changes in our lifetime, certainly in a decade. But, we got this very bad habit of being very adaptable beings. And so, we see spring arrive 3 weeks earlier, and we quickly forget that it used to be 3 weeks later. It seems as if it has always been thus. So we adapt quickly on changes that are very, very quick on a planetary scale, and until a point comes where the tipping point is passed, effectively, and the cascade can no longer be ignored. But at that point, once we reach that point, it's too late to do much about it because of the interconnectedness of the planetary system. But yes, I would definitely be in agreement with you. We are the most dangerous aspect of the risks that our planet is facing today.
If we play out the worst case scenario, as you spoke about, where we continue to exploit the natural resources and we see the eventual downfall of the human race, do you foresee a future in which we will also take down all other living organisms and mammals with us? Or do you see a future where even if the human race goes extinct, other living organisms could continue to thrive on Earth?
Well, I think, in my mind, it seems to me that the scenario in which the human race goes extinct is the one where all the other animals will eventually recover, and life will recover and perhaps take new evolutionary directions that we cannot begin to foresee. More worrisome, perhaps, is a scenario where we hang on to things and we keep mining the Earth for all it's worth until there is nothing left to mine. That is the real worrisome scenario, I think. So I don't want the human race to go extinct. Let me get this straight. I want us to thrive. I want us to, like in Einstein's word, I want us to be able to harness the power of science and technology for humankind's benefit. But humankind's benefit is too narrowly defined presently. We need to encompass the entirety of the biosphere in order to work for the benefit of the planet, effectively.
Well, ladies and gentlemen, I think that's all we've got time for. But as Provost of the College, I'd just like to say 2 words of thanks to Professor Trotta for his amazing tenure as visiting Professor of Cosmology at the College. In addition to his work at Imperial College and the School of Advanced Studies in Trieste, I think we have all seen how he is an extraordinarily good science communicator. And in fact, for his public engagement work, he received the Annie Maunder Medal in 2020 from the Royal Astronomical Society. His award-winning first book, The Edge of the Sky, uses only the 1,000 most common words, I understand, in the English language to recount the history of the universe. And for this, Roberto was named as one of the 100 global thinkers of 2014 by Foreign Policy magazine. Well, some of you have been following his lectures over the last 3 years, since 2019. His first series on cosmology was called The Nature of Reality, which examined our understandings of the fundamental reality of the cosmos and delved into some of the biggest questions in physics. And this was followed by his second series, The Unexpected Universe, where he explored some of the most astonishing aspects of the cosmos, from ghostly particles to hidden harmonies, and explained how a new alliance between human and artificial intelligence can help answer fundamental questions about the cosmos. And this was followed by his current series, The Frontiers of Knowledge. And this has examined the enormous progress in the exploration of the cosmos and the questions this has generated, concluding today with this exploration of the ultimate destiny of life on Earth. Well, throughout his time as a Gresham College visiting professor, he's brought his considerable knowledge of very often extremely complex concepts in astrophysics to those of us, certainly speaking for myself, who are not great experts. And we are really grateful to him for his work. I really hope we'll be able to invite him back here in the future. But for now, Roberto, I'd like to thank you very much indeed.